Hello, this is Gary, and I just want to thank everybody. I have 500 subscribers. I'm trying to build up this channel, and eventually I'd like to start doing some kind of Patreon to where I'll start uh, giving away STL files so everybody can start printing their own animatronics to where they can make their projects move. And I'll have a listing of what servos to get and hardware, just basically everything to get your animatronic to move. But just want to say thank you again. Appreciate all the subscribers. But it's really a fun feeling to get these things to move and create in a way of simple robotics. Most of these videos are posted on my Instagram. I just put up one big collage of all the videos. And there might be some that you may have not seen, but this will get you to see some of the movements and all the parts really you have to design to make these animatronics. And but it's fun to do these things, and you can actually bring these little creatures to life. And that's the whole goal, to eventually have skin on them. I design a lot of things, just to see if I could do it, you know. I do a lot of tests. You know, I get servos and make servo sockets and print the sockets out so I can put the servo in. And then I build up from there, you know, making little movements, you know. I mean, 90% of this is like a lever movement. It's just a simple movement. But making something move, especially when it comes to like these creatures, a lot of it's modular. You know, I'll build the teeth part and then make eyes. And here's servos. Now these are all high-tech servos. You have your large, then you got your standard, and you got your minis, then you got your micros. Now, all servos, I mean, there's thousands of them, and a lot of them have no really torque. You know, they might, I don't know. You have to really study the torque. I mean, these servos right here are stronger than this little one here, but this little servo right here, this can lift 6 pounds. You put a 6-pound weight on that arm, it'll lift it. But you know, I'm not going to be lifting 6 pounds, you know. But this is servo sockets, you know. I designed this, and then I designed the socket for it, and I'll just take that servo that I designed it and got the measurements off of it from a schematic, and I draw the servo out in my design, and I can just slip that right into the socket and work the eyelids. This was maybe a couple of years ago. You see what a kind of a collection of a lot of animatronics. But you know, there's a lot of servos, and which is the key is of all the movements is the servo. And these are like these 9G servos. You know, the torque is, you know, it's strong, you know, maybe a pound, but maybe a little bit more. But it's really good for these tests. You know, when you test a movement and you get it to working really good, but will it pull a silicone skin? Yeah, it might if it's small enough. But the whole goal of this is to where I design all the movements, and I'm working from the inside out. So when I get all the movements that I like, then that way we can work on the skin. But the key is on the skin. What I'm trying to achieve is where it can be uh, designed in like ZBrush or Blender, to where if you make all the movements and you get it all right, then you make a core. Then after you make the core, you can put the core into ZBrush or into Blender, and you can sculpt on the core, and then you can make the skin. But to make the skin, you're going to need a large resin printer. So, like the alien that was on yesterday or the previous video, trying to design it to where the build platform to some of these resin printers need to be large, because after about, I guess, 6 servos, 7 servos, where you'll get a lot more movements inside the skull, and then that way we can actually get some lip and brow and eyelids. But like if you want moving eyes, that's going to take even more servos. So the bigger it is, the bigger the resin printer is going to need to be. We got now. I'm puppeteering using an RC radio, and just wanted to show you puppeteering. I'm puppeteering with an RC radio using a joystick when I talk. Stop. This animatronic I made a couple of years ago. It was one with a lot of pieces. And this was one of those where I just designed it and built it up. And just, a learning process as you build. But most animatronic designs I do is I've gotten where I to one side and just mirror the whole process. And then if there's 4 servos, mirror it, you'll have 8 servos. But usually after a certain amount of time and get the testing and designing, I'll take one of these older animatronics and tear it down and salvage the servos and parts. A lot of these designs that I'm doing, I just they're quite simple movements, and then I'll put that movement on top of another movement. But to have a servo is moving 70 degrees most of the time. And, some of the other servos, a little bit higher price, will go maybe 180 degrees. But you just basically, I like going for torque and then price. But there's also metal. You really want to stay away from plastic gear because they're more able to fail. But all servos can fail, but you have some companies that are better than others, but yet the price seems to be higher. There's rankings of which one's the best, but I'm gonna hope I can, with some of my research, I can point y'all in the right directions of which ones, mainly which ones I prefer using. And I like smaller ones because it's my whole goal is to make small, detailed, a lot of movement animatronics, to where if I can get 8 movements in the face, that'll make the skin look really realistic to me. After I reach a goal of 1,000 people or 1,000 subscribers, I'm able to do other things on YouTube, and there eventually will be advertising. But main thing is that I'll be able to get a Patreon started. But in the beginning, it's just a process of getting subscribers and a lot more viewing time of people watching my videos. So thanks again, everybody, and be sure to tell all your family and friends and just everybody that is into 3D printing to where the things that you print, we can make them move. So, thanks again.